You know, you see it every day. It's the foil in your kitchen, it's the airplanes flying way up in the sky. But how does that simple, everyday aluminum get transformed into the kind of high-performance materials that, well, build our entire modern world? Let's dive in and find out. Right, so we think of metals as being super strong, right? But for the most demanding jobs, I'm talking about the fuselage of a jet or even the casing of your smartphone, pure metal, it just doesn't cut it. So that brings up this really fascinating question. How do we actually engineer a basic element to give it what are basically superhuman capabilities? So our journey really starts by moving beyond the whole idea of a pure metal. We've got to look at the fundamental concept that unlocks all of this amazing potential. And that answer? Well, it's the alloy. The core idea is actually pretty simple. It's just a metallic mixture. But its real power lies in creating something totally new. A material whose properties are way, way greater than the sum of its parts. And you've got to get this. This is the crucial point. Creating an alloy isn't like, just throwing metals into a pot like a fruit salad. Nope, it's a precise science. Every single element is added in a very specific amount for a very specific reason, turning a basic metal into a custom-engineered material.
All right, so if we're thinking of alloying as a recipe, what are the ingredients? Let's take a look at the key elements that give aluminum those superhuman properties we were just talking about.
Think of these as the ultimate spice rack for metallurgists. Each one of these elements, from common stuff like copper and zinc to some more exotic ones like lithium and rare earths, well, each one brings a totally unique character to the final aluminum alloy.
And at the end of the day, the final performance of the material, how strong it is, how it resists rust, whether you can weld it, it all comes down to its chemical composition. The ingredients literally define the outcome.
Okay, so we've got our ingredients. Now for the fun part. What do they actually do? Adding these elements isn't random at all. It's about deliberately engineering specific performance characteristics right into the metal.
This is where the magic really happens. Just imagine you're an engineer for a second. If you need an incredibly strong part for, say, an aircraft, you're going to look for an alloy with copper. If you're designing a complex engine part that has to be cast from molten metal, you need silicon to make it flow like water into every tiny little crevice of the mold. Need to weld a boat hull? Magnesium is absolutely essential. It's this direct, predictable link from the ingredient to the performance.
But of course, there's a catch. In materials science, there is absolutely no such thing as a free lunch. When you boost one property, you almost always have to sacrifice another. It's a constant balancing act.
So this right here illustrates that classic trade-off perfectly. You can make an alloy incredibly hard, right? So it resists scratches, kind of like a high-end watch face. But that hardness, it often makes the material more brittle, which means it might just shatter on impact. On the flip side, you can make it really ductile, able to bend and stretch without snapping, but that usually makes it softer and way easier to dent. You simply cannot have the maximum of both.
And then there's this other subtle but really vital distinction between strength and toughness. Strength is about resisting force without bending, but toughness is about absorbing energy without breaking. Think about it like this. A ceramic plate has really high strength, but it's not tough at all. You drop it and it shatters into a million pieces. A car bumper, on the other hand, is engineered for toughness. It's designed to deform and absorb the energy of an impact, protecting whatever's behind it. That's the difference.
And believe me, the list just keeps going. Beyond strength and toughness, engineers are also dialing in all these other critical properties. Can it be easily cut and shaped by a machine with super high precision? That's machinability. Can you join it together reliably with a clean, strong bond? That's weldability. And can it stand up to the elements without falling apart? Well, that's corrosion resistance. So, okay, with thousands of different recipes creating thousands of different materials, how on earth do we keep track of it all? Well, that's where a system comes in. A library, basically, for organizing all these incredible alloys. First up, alloys get sorted by how they're actually made. Casting alloys, they're created by pouring liquid metal into a mold, which is fantastic for really intricate shapes, like an engine block. Wrought alloys, though, are mechanically worked. They're rolled, forged, or extruded into their final shape. And that process, it generally results in a stronger, tougher final product like the wing of an airplane.
Another big difference is where the stuff comes from. Primary aluminum is made from freshly mined ore, and that gives you the absolute highest purity. Secondary aluminum, on the other hand, is made from recycled scrap. And this is just fantastic for sustainability, since it uses only a tiny fraction of the energy it takes to make primary aluminum.
And finally, we get to the actual catalog system. Wrought aluminum alloys are organized into a series from 1,000 up to 8,000. This number instantly tells an engineer what the main ingredient is. For example, a 2,000 series alloy has copper as its primary element, while a 6,000 series alloy has magnesium and silicon. It's a really simple, kind of elegant way to navigate this huge library of materials.
So, there you have it. From a simple definition to a really complex library of engineered materials, that's the world of advanced aluminum alloys. It really makes you wonder, though, as we keep mastering these recipes and introducing new, more exotic ingredients, what challenges will these future materials let us solve? I mean, what will we be able to build tomorrow that seems completely impossible today?